Hello, good morning. I am going to be working through this Quiz 1 study guide for the next, hour or so. Many of these questions will appear on the quiz in some kind of similar form, and I've especially marked the important ones with an asterisk. So make sure to check those out and make sure you know how to do certainly all the ones with an asterisk, and then the remaining ones are simply just kind of iterations of those questions. Okay, the first question has us finding the derivative of this polynomial, but it specifically has us doing it using the limit process. So in other words, if we simply write down the derivative using power rule, it would be 6x minus 4. That would be correct, but it would not get any points because you haven't used the correct solution method. So we actually have to use the definition of the derivative, which comes from the limit. And so I've given that to you here on the study guide, but on the quiz you won't have this. So make sure you have this limit definition of the derivative memorized. You'll also notice that I've replaced the delta x that you might have seen before with an h. That's just a way of making it easier because sometimes people get confused because this delta x looks very similar to an x and it seems almost like two variables, a delta and an x. So that can be a little confusing. So for simplicity, I've used an h here. And so the derivative is simply defined as the limit as h approaches 0 of f of x plus h minus f of x all over h. And so all we do now is we simply plug in our function into this formula here. And so we're going to do that. F prime of x, remember the prime means it's a derivative, is equal to the limit as h approaches 0 of, and now here we're going to do f of x plus h. And so that means we need to plug in x plus h into our function here. So f of x plus h is going to be 3 times x plus h squared, right? I'm just plugging in x plus h and replacing that with, replacing the x's with x plus h's. 3 times x plus h squared minus 4 times x plus h, and then the plus 1 remains the same. So that's f of x plus h. And then I need to subtract out f of x. So I'm going to do minus parentheses 3x squared minus 4x plus 1. And that's all over h. And so in the end, I'm probably going to be left with a bunch of h's in the numerator, and most of them should cancel out. Sorry, I'm reading email. Okay, sorry about that. All right, so remember when we're doing limits, we still need to keep writing the limit symbol as we go through this problem. So we're going to keep writing that limit as h approaches 0. And then now all we need to do is expand the numerator and get all those x's and h's by themselves. So first we're going to expand x plus h squared. It's going to be x squared plus 2xh plus h squared. And then we're going to distribute the negative 4 here into the x and the h. That's minus 4x minus 4h. And then plus 1. And then here, remember, it's a minus sign, so that needs to distribute across the parentheses. So it's going to be minus 3x squared plus 4x minus 1. Okay? So I'm almost done expanding. I just need to carry this 3 into the parentheses. So I'm going to write limit as h approaches 0 of 3x squared plus 6xh plus 3h squared minus 4x minus 4h plus 1 minus 3x squared plus 4x plus 1. So that looks very long, but thankfully, almost everything is going to cancel. So let's look carefully at what cancels. It's very important to do this step well to make sure you don't forget to cancel something or cancel something that isn't canceled. So let's look at this 3x squared. That's canceled by minus 3x squared here. So we can cross that out. Then we have a plus 6xh. That's not canceled out anywhere. 3h squared, not canceled out. Okay, minus 4x is canceled by a plus 4x here. Minus 4h, not canceled. Plus 1, and then that's canceled by a minus 1. And so what we're left with is 6xh plus 3h squared minus 4h. And that's all over h. And good news, the h's will cancel. So we're going to have the limit as h approaches 0 of 6x plus 3h minus 4. Okay? So now we are able to plug in h equals 0 because if we had done that previously, we would have gotten a 0 over 0 error, right? But now we're all good. And so we can plug in h equals 0, and we're left with 6x minus 4. Okay, and that's our answer. Because we've plugged it in, we can drop the limit symbol in the final step. Okay, so hopefully that makes sense. It's a lot of algebra, and that's probably the hardest part, is getting the algebra right. So in your final thing, as your final step, if you have done it right, the h's should always cancel out in the numerator and the denominator. And you should always be left with something like this. Something without a h in the denominator anymore, and perhaps some h's left behind in the expansion. And obviously, you can always go back and check and use the easier power rule to just check that your answer is right. Let's go to the next question. Question 2, find all values of x such that the tangent line to f of x equals 2x cubed, blah, 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 is horizontal. Okay, so this is actually very easy, but it looks a little tricky, right? The idea is that whenever we have a tangent line, that's basically just a derivative, right? The derivative is the slope of the tangent line. And if the tangent line is horizontal, then that means it has slope 0. So in other words, that means the derivative of the function must be 0. So essentially, we're looking for those values of x such that the derivative is equal to 0. So we can write that as our first step. F prime of x equals 0. So what is f prime of x? Well, we can just apply power rule. Our first term is 2x cubed. So that's 2 times, okay, and then with power rule, remember, we're just taking out the exponent, putting that as a coefficient in the front, and then subtracting 1 from the exponent. So the derivative of x cubed is 3x squared. Next, we have 3 times x squared, so the derivative of that is 2x. Then the derivative of minus 12x is minus 12, because the derivative of x is 1. And then finally, 7, the derivative of that is 0, because it's a constant. So we're looking for the values of x such that this expression equals 0. We can expand this. That's 6x squared plus 6x minus 12 equals 0. Now we can divide everything by 6, because everything shares a common factor. So that leaves us with x squared plus x minus 2 equals 0. This is something we can factor, and that's just x plus 2 times x minus 1. So the answers are x equals negative 2 and positive 1. And so essentially, for these values of x, the derivative is going to equal 0, which means that the tangent line to the original function will be horizontal and have slope 0. Hopefully that makes sense. Next question, find the equation of the tangent line to the graph of the function f of x equals x plus 3 over x squared plus 1 at the point 2, 1. All right, so for this question, we're going to need to use point-slope form, because the idea is that we're going to try and find the derivative of f of x at this particular point, and that's going to tell us the slope of the tangent line. And so we're going to use that slope, and then because we know a slope and we know a point, that means point-slope form is going to tell us what the equation of the tangent line. So it's very important that you have point-slope form memorized. Remember, that's y minus y1 over x minus x1 equals the slope, m, okay? Sometimes this is also written as y minus y1 equals m times x minus x1. And you can see that those are obviously equivalent. So first, let's calculate the derivative of f of x, and then we're going to have to plug in x equals 2 to find what the slope is at that particular point. So let's calculate the derivative. F prime of x equals, all right, here we're going to have to use quotient rule. So remember, that's low d high minus high d low over low squared. So first, we're going to do low d high. So low is x squared plus 1. And then the derivative of the top, okay, the top is x plus 3, and the derivative of that is 1, because that's the derivative of x, plus 0, because that's the derivative of 3. Okay, and then minus high d low, so minus high, which is x plus 3, and then the derivative of the bottom is 2x plus 0, just by power rule. And of course, that's all over x squared plus 1 squared, right? Low squared. Low d high minus high d low over low squared. And all that remains is simply to expand the top. So this is going to become x squared plus 1 minus x plus 3 times 2x over x squared plus 1 squared. I don't have to expand the bottom because I know I'm going to plug in numbers later anyways. And so that's x squared plus 1 minus 2x squared minus 6x all over x squared plus 1 squared. And I can collect some terms here. So that gives me negative x squared minus 6x plus 1 all over x squared plus 1 squared. Okay, so that's the derivative. And now I need to find the slope of the tangent line to this graph at this particular point, okay? And this point is simply the point where x equals 2, right? Because that's the coordinate. And so essentially, I'm interested in the derivative of the function at x equals 2. And that'll be the slope of my line. So that's f prime of 2, right? Because that's where x equals 2. And I can calculate that simply by plugging in 2 into my equation here. So that's negative 4 minus 12 plus 1 over, okay, 2 squared plus 1 is 5, so it's over 25. And you can check for yourself that this equals negative 15 over 25, which is negative 3/5. Okay, so that's the slope. That's m. Okay, that's the slope of my line. And so, essentially, I know that the tangent line also has to pass through the point itself. And so I'm looking for the equation of a line that passes through this point with slope negative 3/5. And so that means I need to use point-slope form. So that'll be y minus, and what is y1? y1 is going to be 1, because that's the y-coordinate of my point. So that's y minus 1 equals m times x minus 1, right? Sorry, m times x minus x1. And so m is negative 3/5. X minus, what is the x coordinate? It's 2. So x minus 2. If I expand this, that gives me y minus 1 equals negative 3/5 x plus 6 over 5. So if I bring the 1 to the right side, I'm left with negative 3/5 x plus 11 over 5. That's my answer. Let's do the next one. Find the derivative of these following functions. I have 4, 5, 6, 7, 8. Oh my goodness, that's a lot of questions. So I need to find the derivative of this function, and here I'm going to use product rule because I have a power and then I have a trig function. So product rule will be helpful. Perhaps it's best to rewrite this first as x to the power of 1/2, because that makes it more easy to see how we would use power rule here. So instead of a square root, that's also x to the 1/2 power. X to the 1/2 times the tangent of x, then I can use power rule. So first I'm going to take the derivative of the first term, which is x to the 1/2, and then multiply by the second term, leaving that alone. So the derivative of the first term is 1/2 x to the negative 1/2, right? The power just comes to the front as a coefficient, and then I subtracted 1 from the exponent. So that's half minus 1, which is negative half. Then that's times tangent x. I leave that alone. Then I add, for the second term, I leave the x to the 1/2 alone. And then I take the derivative of tangent x, which I've memorized as being secant squared x. And so that's my answer. This is already pretty simplified, but if you wanted, you could also have written 1/2 square root x tangent x plus the square root of x times secant squared x. So that's also fine. So remember, you're going to need to have the derivatives of all the trig functions memorized. Just to recap, derivative of sine x is cosine x. Derivative of cosine x, let's write cosine on the right side. You'll see why. Derivative of cosine x is minus sine x. Derivative of tangent x is secant squared. Derivative of cotangent x is negative cosecant squared. And derivative of secant is secant times tangent. And derivative of cosecant is negative cosecant times cotangent. Okay? So you can see a lot of the patterns here, which make it very easy to memorize. If it starts with a c, then the derivative is always going to have a minus sign, right? That's why I put them all on the right side. Tangent and cotangent both come out to something squared, and it's always either secant or cosecant. And then you can also see the patterns and the similarities between secant and cosecant. So it's actually very straightforward for memorizing, but it does need to be memorized because you will not have these formulas on the quiz. Let's do the next one. This is also just an application of product rule, but we have to do it twice because there are two different terms that are being subtracted from one another. So this first term is 4x squared times cosine x. So we're going to take the derivative of 4x squared and then take the derivative of cosine x. So by applying power rule, we have the derivative of the 4x squared is going to be 8x. That's 8x cosine x, right? We took the derivative of the first one and left the second one alone. And then we need to add 4x squared times the derivative of cosine, which is minus sine x. Okay, so that's my first term. And then my second one, be careful about this minus sign. Make sure not to forget that you need to have a parentheses around the derivative of what you're going to calculate here. So first, I'm going to calculate the derivative of x cubed, which is 3x squared, and that's times cosecant x, plus x cubed times the derivative of cosecant, which is minus cosecant x cotangent x. Okay, and now I simply need to expand this and distribute all those minus signs. So I'm left with 8x times cosine x minus 4x squared sine x. Okay, then it's minus 3x squared cosecant x. And finally, these two minus signs are going to cancel with one another, so I'm left with plus x cubed cosecant x cotangent x. All right, and that is simplified enough. Let's do the next one. Here we need to use quotient rule. So remember, that's low d high minus high d low over low squared. So low x plus sine x times d high, so that's the derivative of 3, which is 0, because it's a constant. So that minus high d low, so 3 times the derivative of x plus sine x, which is 1 plus cosine x. And that's all over low squared. Okay, so if I simplify the top, this is going to reduce to 0, and so I'm left with minus 3 times 1 plus cosine x all over x plus sine x squared. And I'm done. Let's do the next one. Here's just product rule. So that's 2x secant x plus x squared times the derivative of secant x, which is secant x tan x. Secant x tangent x. And that's it. Well, you could have also factored out the secant x, I guess. And x, right? So that gives you x times secant x times parentheses 2 plus x tangent x. So that works too. But it's a little clunky, so both are acceptable. As a general rule, if you're afraid of getting things wrong, you don't necessarily have to simplify all the way. I likely won't take off points if you leave it unsimplified, so that can save you some opportunities for errors, I guess. Next one. X squared plus 1 times tangent x. This is a great place to use product rule. So we're going to take the derivative of the front, so that's 2x. Right, that's the derivative of x squared plus 1, because the derivative of x squared is 2x, and the derivative of 1 is 0. So that's 2x, just going to get rid of this parentheses, 2x tangent x plus the derivative of, we're going to leave the x squared plus 1 alone, right? And then take the derivative of tangent x, which is secant squared. And I'm done. Next one, here I need to use quotient rule. Sometimes, you might be there might be a shortcut because you might be able to factor something here, but here we can't, because the top is x times x plus 1, which doesn't cancel out with anything in the denominator. So we're going to use quotient rule, low d high minus high d low over low squared. So low d high, low is x plus 2, and then the derivative of the numerator is 2x plus 1 minus high d low, so high x squared plus x times the derivative of the denominator. So d low is just 1, because that's the derivative of x plus 2. And that's all over x plus 2 squared. So all that remains is needing to simplify the top by expanding it. I probably actually would take off points if you didn't expand it, because that's a very blatant simplification that needs to be done. So we're going to do that 2x squared, just FOIL, right? 2x squared plus x plus 4x plus 2 minus x squared minus x. Remember, this minus sign needs to distribute across both terms. That's all over x plus 2 squared. And so all I need to do now is collect like terms. So my x squareds, I have 2x squared and a minus x squared, right? So those will partially cancel. I'm left with x squared. And then I have 5x minus x, so that leaves me with 4x. And then I have a plus 2 at the end. That's the answer. Next one, here we're just going to use product rule on this term, and this term we have memorized, right? So that's 3 times sine x, because the derivative of 3x is 3. 3 sine x plus 3x, and then the derivative of sine is cosine. And then the derivative of secant is secant x tangent x. Okay, so here there are constant coefficients, and remember that those are unaffected by derivatives, and so you can just keep them on the outside and differentiate the inside. Okay, so that's my answer. Next, okay, we have a cube root here. Let's rewrite that as a power so we can apply power rule more easily. So we rewrite this as 5 times x to the power of 1/3 times cotangent of x. Now we're going to use power rule. So the derivative of the front is 5 times 1/3, because that's the power, right? 5 times 1/3 times x to the power of -2/3. Why -2/3? That's because we're simply going to be subtracting 1 from the exponent, right? That's power rule. And then 1/3 minus 1 is -2/3, which you can check for yourself. It's important to be careful with these fractions, right? Okay, and then, so that's the derivative of the front, so we're going to leave the back alone. And then plus 5x to the 1/3 times the derivative of cotangent, which is negative cosecant squared of x. Okay, so I'm going to simplify this a little bit. I'm left with 5/3 x to the -2/3 cotangent x minus 5x to the 1/3 cosecant squared x. That's my answer. All right, finally done with those. So let's keep doing these. How many pages left? This is very long, isn't it? Oh my goodness. Well, it's my fault for writing it. Let's do the next one. Find the derivative of f of x equals x squared minus 2x with the limit process. So recall the definition of the limit that we had before. F prime of x equals the limit as h approaches 0 of f of x plus h minus f of x all over h. So we're just going to plug in f of x, which is x squared minus 2x. So that's the limit as h approaches 0 of x plus h squared minus 2 times x plus h minus parentheses x squared minus 2x. Don't forget the parentheses. Okay, I'm just going to expand this and not talk. My mouth is getting dry. Okay, canceling terms. That's all that will cancel. Okay, and then in the final step, I can drop the limit symbol because I'm plugging my value, h equals 0, into it. But otherwise, the limit symbol needs to stay in the expression. Oh, sorry, there's a typo. 2x minus 2, isn't it? And you can check just by using power rule. It's 2x minus 2. Let's do another one. It's helpful to have the definition written out before you do anything. canceling. And finally plugging in h equals 0. Quick sanity check, is that what I think I should have gotten? 4x plus 3 plus 0, so it looks good. All right, this one's a little harder because there's a fraction. And we're not very good at fractions, are we? So let's write the definition first. Then plugging in. Okay, I'm going to multiply, try to get a common denominator in the numerator first. So I'm going to multiply this fraction by x over x, and this fraction by x plus h over x plus h. It's all over h. Okay, simplifying the top. Remember, you need parentheses here because the minus sign is over the entire fraction, right? And then dividing by h is essentially equivalent to multiplying by 1 over h, right? So what do I have in the numerator? I have minus h, because the x's cancel out and the minus sign distributes to the h. Minus h times hx, because this h is also multiplied here. And then the h's will cancel out in the numerator and denominator. Actually, I don't need to go there. Now, all I need to do is plug in h equals 0, because I'm not going to have any more divide by 0 errors now, and I'm left with negative 1 over x squared. Because x plus h is just, that's just x when h equals 0. And is that what I would have expected with power rule? Well, we can see f of x is just, use a different color here. F of x is just x to the negative 1, right? Because the reciprocal is a negative 1 power. And so that means f prime of x is going to be negative 1 times x to the negative 2, because minus 1 is minus 2. So that's just negative 1 over x squared, which is exactly what I expected. Next question. Okay, there's a star here, so make sure you know how to do it. Looks totally different from what we've been learning, but actually it's totally exactly what we've been learning, because the velocity is actually the derivative of position with respect to time. And so if we're given position, right, this is physics, isn't it? If we're given position as a function of time, then to find the velocity, we're just going to take the derivative with respect to the variable t, which is time. You know, if any of you guys are taking physics, then you should have memorized the kinematics equations by now. And they look kind of complicated, but you can actually see that they're derived using calculus. So, for example, you guys learned something like x equals x naught plus v naught t minus 1/2 a t squared, where a is the acceleration. Well, guess what? The velocity is just the derivative with respect to time of position. And so what is that? We know that. We just use power rule. And that's going to be v naught minus 1/2 a times 2t, right? Because the derivative of t squared is just 2t. Sorry, this is a plus, isn't it? it's only minus if a is the gravitational constant. So what is that going to be? Oh, it's exactly what we memorized. V naught plus AT. And then what is acceleration? Well, that's nothing other than the derivative of velocity. And so what is that? That is just A. So you see that kinematics is essentially just the study of calculus. So let's do that here. Well, you didn't need to know any of that if you're not taking physics. Here, we're just interested in the derivative. So the velocity, we'll call that v, is just the derivative of y with respect to time. And we know how to do that. That's just going to be negative 32t plus 12 using power rule, right? Because derivative of t squared is 2t, and that times negative 16 is negative 32t, and the derivative of 12t is 12, and minus 3 is just a constant, so that's 0. And all you need to do now is plug in to t equals 2.5 to find the velocity at time t 2.5 seconds. So that's v of 2.5 equals negative 32 times 2.5 plus 12. What is this? 32 times 2.5, that's 80. So it's minus 80 plus 12. Well, I hope it is. Otherwise, this is wrong. So the answer is negative 68. Hopefully that's right. It's been a while since I've done much arithmetic. Okay, next one. Find an equation of the tangent line to the graph of the function f of x equals 3x squared minus 4x plus 5 at the point 1, 4. So we've done a similar one before, haven't we? We just find the derivative to find the slope of the line, and then we use point slope form, right? Because this is just the point where x equals 1. And so to find the slope, we just calculate the derivative and then plug in x equals 1. So the derivative is by power rule, just going to be f prime of x equals 6x minus 4. All right? 3 times 2x minus 4. 6x minus 4. And so the derivative, or the slope of the tangent line at x equals 1 is going to be f prime of 1 equals 6 times 1 minus 4, which is 2. So that's our slope m. And then we just use point slope form using this point and that slope. So that's y minus y1, which is 4, equals the slope m, which is 2, times x minus 1. So that's y equals 2x minus 2 plus 4. So y equals 2x plus 2. That's my answer, which I hope is right. Is this the last question? Almost done. Okay. All right. Given the equation f of x equals 2x cubed, blah, 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 find all the values of x such that the tangent line is horizontal. Okay, so remember, if it's horizontal, that means the slope is 0. So we're interested in finding all the values of x such that the derivative is equal to 0. So what is the derivative? That's f prime of x equals 6x squared minus 30x. Sorry, I'm going a bit quickly because I'm hungry and there's food in the, there's food upstairs right now. I'm at school, by the way, so. Okay, 6x squared minus 30x. I'm very distracted now. Okay, minus 30x plus 36, and then the derivative of 10 is 0. My stomach is growling. All right, so we're interested in finding all the values of x such that this derivative is equal to 0. So we're going to set this equal to 0. I won't write it again. Equal to 0. So to help me factor, I'm going to first divide everything by 6, because they all share that factor. So x squared minus 5x plus 6 equals 0. And that I know how to factor, don't I? It's x minus 3 times x minus 2. And so the answer is x equals 2 or 3. So those are the possible values of x such that the tangent line to the original function is horizontal. Next. Very similar, isn't this? We just find the derivative and find the values of x such that the derivative is 0. So the derivative is 3x squared minus 6x plus 3. Divide everything by 3, x squared minus 2x plus 1 equals 0. And that's easy to factor, right? That's just the perfect square of x minus 1. The answer is equal to x. The answer is x equals 1. So that's the only value of x such that the tangent line is horizontal. All right, and that's the last question. Hopefully this is helpful. If you've done all of these and still want more practice problems, just email me and I'll happily give you some more. But hopefully this has helped you to prepare well for the quiz next week. So good luck on that.